Okay, this lesson is on section 9.1, reflections. It helps if you have an index card that you've highlighted the edges. The reason for that is so that the index card can more easily be seen instead of white on white. So basically, remember that a reflection is a flip over a line of reflection. So you have an image. It's actually a pre-image is what they call it, which is the original one. And you reflect it over a particular line, and the line can be vertical, horizontal, or slanted, whatever. And whenever you reflect it, it has to be maintain the same shape that it had before and the same dimensions. Just like as if you were putting a mirror next to it, it would just flip over to the other side. So the steps are here. The first step is to draw a perpendicular line from each vertex to the image. And so what we're going to do is I'm going to use a colored pencil. So it's kind of easier to see between the old and the new, although this one's blue. So to ensure that you have a perpendicular line, I just draw a little perpendicular symbol in the corner of my index card because the index card was cut at a 90-degree angle. And so remember, the perpendicular is between the point, the old vertex, and the new. So we're going to draw like a little perpendicular segment here. And this, and we need to look at measure the distance too. So instead of using a ruler to measure the exact amount, it doesn't really matter the exact amount. You just want the amount on the opposite side of the line of reflection to be the same amount. So you draw a perpendicular line, which I did, from the line of reflection to the vertex, and then you're going to measure it and put the new vertex on the opposite side the same distance, and so it's right here. So the old vertex A was here, and the new vertex, which we call A prime. Prime is the little mark above the letters for the new, that corresponds to the new vertex of the new image. All right, so then let's look at B. We're going to measure from B, the vertex, because we want to flip this over this line of reflection. And so if you'll notice, B goes about to there, all the way in a perpendicular way. So this distance on this side of the line of reflection has to equal the same distance on the other side of the line of reflection, which would go all the way down to this corner. So this is B prime. This is where B would be reflected by the same amount. And again, it has to be perpendicular. So C, from vertex C to the line of reflection, is right here. It's the lowest one. You got to kind of keep track of your little tick marks. And we'll draw a little perpendicular line. And this distance, it's hard to see, needs to be the same distance on the opposite side of the line of reflection, which would be right here to this corner. So this is C. Then you use a straight edge. Don't use your index card because the index card is kind of flimsy as far as drawing lines. So use a straight edge like a protractor or ruler or something. And then you connect the vertices of the image that you just drew, the transformed image. Transformed can be reflection, rotation, or combinations thereof. It can be translations, which is sliding. So A has been reflected over by the same amount, B has been reflected over, and C has been reflected over. So that's how you would do it. And again, you mark with primes. All right, so let's do this with these images. Okay, same method. Now the difference here is that if there is a point that is on the line of reflection, the new point is also on the line of reflection. So K prime is actually the same exact point as this one. All right. Okay, so we'll use a different color. So we're going to measure in a perpendicular way from J to the line of reflection. And it's this distance, and so we're going to get the same amount, again, in that perpendicular way to the other side. So this is J prime. K prime is here. And then H, again, it has to be perpendicular with the line of reflection. And so it goes to about here, like this, kind of this distance or whatever is the same distance as on the opposite side. to the corner here. So this is H prime because it corresponds to H. And then you use a straight edge to connect the vertices of your reflected image. And all right, let's do the same one over here. This one's a little more complicated because look, you've got part of the image on the bottom of the line and part of the image on the top. So M and N are going to be down here. P is going to be up there, and L and O will be in the same position as they are currently. All right, so let's look at this one. So L and L prime are the same. I'm just going to change it. And O prime are going to be the same because they lie on the line of reflection. So let's look at P. Again, you're looking from P perpendicular to the line of reflection. It goes to here. So then on the opposite side, in a perpendicular way, and again, if you line up the previous vertex with the line of reflection in here, then that automatically allows it to be in a perpendicular way. All right, so let's look at M. M, perpendicular to the line here. Right, that's going to go about this far. And then on the opposite side, M will be here. And then N in a perpendicular way. This is perpendicular. It's going to go to here. And N prime. And then use a straight edge. And since this is kind of complicated, the original was L to M, N, O, P. So we're going to do the new ones, L prime, M prime, and so forth. So L prime to M prime. So it's like the same letter, L, M, N, O, P. L, M, N, O, and then P. Okay, and that image is now reflected over the line of reflection. Okay, so let's look at the next part of the class notes. The next one is whenever you're drawing reflections, but in the coordinate plane. Now this can be a little bit easier if it's a vertical or horizontal line. So if it's vertical or horizontal on the coordinate plane, it's not quite so complicated. If you have to reflect over a slanted line like y is equal to x, you definitely need to do something called mapping. And so if you're reflecting over y is equal to x or a slanted line, definitely map the points, and we'll practice it with the vertical and the horizontal line, even though, again, like it's not as useful necessarily. But if you get into the habit of mapping the points, it helps to not make mistakes. Okay, so if you're reflecting a point over the x-axis, it says in the x-axis, but like if you, in English, we would think of it as like over the x-axis. So when you reflect a point over the x-axis, that means what was above is below, what was below is now above. If it's in the y-axis, what was on the left of the y-axis is now on the right, and vice versa. And then if you reflect a point over, or a point or an image over the line y is equal to x, you're going to exchange the x and y coordinates or switch places. Up here, if you reflect a point in the x-axis, you just multiply the y coordinate by -1. To reflect it over the y, you multiply the x by -1 and then just plot the new points. So we'll practice that. So this one has a quadrilateral with these points, and I've already drawn it here, and you want to reflect it over the x-axis. So here's my line of reflection in yellow, which means the points that are above the x-axis are now going to be below, and the points that are below are going to be above, and any point that's on the actual line of reflection will just stay there. All right, so up here it says if you reflect it over the x-axis, then you just multiply all the y coordinates by -1. So that means the x coordinates will stay the same. This is the old point D for the pre-image, and the new point D prime. You just multiply the y coordinate by -1. So the x coordinate stays the same, but the y coordinate is multiplied by -1. The x and the y is multiplied by -1. The x and the y is multiplied by -1. This is called mapping, where you write out the old points of the pre-image, and then you do the math for the new points, and then it guarantees. You could also count the units above or below the line of reflection if it's vertical or horizontal. So in this case, G is 1 unit below the line of reflection, so it's going to go 1 unit above the line of reflection whenever it's reflected. D is 3 units above, so D prime will be 3 units below. F is 2 units below, so F prime will be 2 units above. And E is 4 units above the line of reflection, so E prime will be 4 units below. And then you draw your image that has been transformed. In this case, it's been reflected. Okay, so the GF that was here is now above, and the DE that was above is now below. Okay, let's move on. So if you want to do the same thing, but over a different line, but it's still a vertical or horizontal line. So x is equal to -1. If you want to reflect it over x is equal to -1, here's your line of reflection. G and G prime are the same point because they lie on top of the line. F went 2 units left, so F prime is going to be 2 units right on the exact horizontal line. H was 1 unit to the left of the line of reflection, so H prime is going to be to the right of the line of reflection. You no longer care about the axis anymore. You're only looking at the line of reflection. And then when you're done, you don't want to make your dots too big. Notice my dots are smaller. The ones from the curriculum are kind of large dots. You can become very inaccurate if you have dots that are really, really large, because then when you're connecting them, they don't look as good. All right, in this case, you want to reflect it over the line y is equal to 1. And that means that's this line. This is the line of reflection. So H, which is 1, 2, 3 units below the line, will be 1, 2, 3 units above the line. So this is now H prime. G is 3 above, so G prime will be 3 below. F is 4 above, so F prime will be 4 below the line of reflection. Okay, and then you just connect them. Okay, and then same thing here. A is 3 units to the left, so A prime will be 3 units to the right. Again, we're going left, right because the line of reflection is vertical. We went up, down because the line of reflection was horizontal. D was 2 to the left, so D prime will be 2 to the right. C is 2 to the right, so C prime will be 2 to the left. B is 3 to the right, so B prime will be 3 to the left of that line. And then you just complete the image. Okay, same thing here. You're going A and A prime will be the same point because it's on the line of reflection. B is 2 above, so B prime will be 2 below. C is 2 below, so C prime will be 2 above. D is 3 below, so D prime will be 3 above. Okay. All right. Last thing to look at is just to remember that if it's a diagonal line, then it becomes a little bit more complicated. So I'll continue that in the next lesson.